Hi, this is a subsequent class of the previous lecture. Remember, when you assign an IP address to your computer or laptop, you have to fill three major entries: IP address, subnet mask, and default gateway. IP address information we have already covered in our previous lecture. Now we need to understand what is subnet mask. The subnet mask determines the network portion and the host portion. Network address cannot be used as an address for any device that is attached to the network, such as hosts, router interfaces, etc. Hosts on a network can only communicate directly with devices if they have the same network ID, or same network, or same subnet. The subnet mask is which tells you what part of the IP address is the network portion and which part of the IP address is the host portion. When getting an IP address, either a host address or a network address, from an ISP, they also provide you with a subnet mask, which is known as the base network mask. A 1 bit in the subnet mask means that the corresponding bit in the IP address should be read as a network number. A 0 bit in the subnet mask means that the corresponding bit in the IP address should be read as a host bit. /sign tells us how many 1 bits are in the subnet mask. Subnet masks do not have to end on natural octet boundaries. Network addresses have all zeros in the host portion of the address. In this lecture, we are talking about the flat subnet mask method. We will cover CIDR, VLSM or subnetting in our upcoming lecture. Let's understand classful IP addressing. In the early days of the internet, IP addresses were allocated to organizations based on request rather than actual need. When an organization received an IP network address, that address was associated with either Class A, Class B, or Class C. This is known as classful IP addressing. The first octet of the address determined what class the network belonged to and which bits were the network bits and which bits were the host bits. There were no subnet masks. It was not until 1992 when the IETF introduced CIDR, classless interdomain routing, making the address class meaningless. This is known as classless IP addressing. For now, all you need to know is that today's networks are classless, except for some things like the structure of Cisco's IP routing table, and for those networks that still use classful routing protocols. We have three major classes for network allocation: Class A, Class B, and Class C. Class D and Class E are also available. However, they are for different use. Class A addresses have 2,147,483,648 possible IPv4 addresses. There are 126 Class A addresses available. Only large organizations such as the military, government agencies, universities, and large corporations have Class A addresses. In Class A, 16,777,214 host addresses, 1 network address, and 1 broadcast address can be used. The first octet starts with 0 and 127, have special meaning, and are not used. If you see an IP address whose first octet number starts from 1 to 126, you can easily recognize the IP address belongs to Class A. In Class B address, 65,534 hosts addresses, 1 network address, and 1 broadcast address can be used. In Class B, there are 16,384 networks possible. Class B addresses are assigned to large organizations including corporations, such as Cisco, government agencies, and school districts. In Class C, 254 host addresses, 1 network address, and 1 broadcast address can be used. Also, there are 2,097,152 possible Class C networks that can be deployed. The network portion of the IP address was dependent upon the first octet. There was no base network mask provided by the ISP. The network mask was inherent in the address itself. The Class D address begins with binary 1, 1, 1, 0 in the first octet, and first octet range will be 224 to 239. The Class D address can be used to represent a group of hosts called a host group or multicast group. Class E addresses first octet of an IP address begins with 1, 1, 1, 1. Class E addresses are reserved for experimental purposes